Let us now look at the equation of a chord bisected at a given point. So after this module, what you'll be able to do is, if I give you a circle, and if I tell you that okay, there is a point in this circle whose coordinates are x1, y1, and I need you to find me the chord which passes through this point such that this point is bisected into two halves at that point, then you'll be able to get this equation of this purple line directly. So let us look at the formula for that. So here is your circle. I've taken a general circle. So the center will be minus g, minus f, and my point P is x1, y1, right? This pink line is where your point is bisected, right? This pink line is what is bisected at this point x1, y1. So I need to get the equation of this pink line. Let's see how we can do that. We already know a point on the pink line, that's x1, y1. If I can get the slope of the pink line, then I can use the slope point form to get the equation. So first of all, I'll get the slope of CP because I know P, I know C, I know 2 points. So I can use the 2-point form to get the slope of CP. So if I get the slope of CP, then slope of the line will be minus 1 by slope of the CP. So it's like m of line into m of CP is minus 1. Why? Because they are at 90 degrees. This is coming from your circles, right? So on a chord, if I drop a perpendicular from the center, then that perpendicular will bisect the circle, bisect the chord into two halves. So what I assumed was this point P is bisecting the chord into two halves. So that means CP has to be perpendicular to the chord. That is the property. So both of them are perpendicular. So the product of slopes is minus 1. So if I know this, I can get the slope of the line, which is minus 1 by slope of CP. Now I can use the slope point form to get the equation of the line. And when you rearrange on both sides and add C, so I have rearranged on both sides and I have added C on both sides of the equation. So basically after you cross multiply, just add C on both sides, you'll get this equation. So if you can see, this is your S1, your LHS is your S1 and your RHS is your S11, right? So if this is your point x1, y1, if this is your point x1, y1, then what is S1 equal to 0 for this? S1 equal to 0 is xx1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c. We've already seen that, and that is what your LHS is. And what is your S11? You'll just put the point in the circle's equation, so that will give you x1 square plus y1 square plus 2gx1 plus 2y1 plus c, and that's your RHS. So S1 equal to S11. What will this give you? This will give you the equation of the pink line directly. What is the speciality about the pink line? The pink line is that chord which is bisected at this point. So if I have a circle, if I have a point, there can be infinite chords passing through this point, right? But there will be only one chord, that is your pink chord, which is bisected at that point. The equation of this chord is got using this formula. So remember this. Once again, as I told you, this particular formula for equation of a chord bisected at a given point, we are studying this for circles, but it will be valid for parabola, hyperbola, ellipse, everything, right? So until now, we have seen that equation of a tangent is S1 equal to 0 when the point is on the circle. The equation of chord of contact is S1 equal to 0 when the point is outside the circle. We have seen S1 equal to S11 is equation of the chord bisected at a given point. We've also seen S1 square is equals to S into S11, which is the equation of pair of tangents from a point outside the circle. All these results are valid for all the geometrical figures that we will see later. With this, we complete the equation of a chord bisected at a given point. Let's move on to the next subtopic.